I'm gonna show you one of the coolest things you ever seen. Are you ready for it? All right, here we go. Boom! That is a nuclear explosion. That is it. All right. So these are nuclear explosions. As you can see, it's amazing to see the amount of power, or yeah, the amount of energy that is created when we're able to split uranium, which is. Hi, welcome back. This is Mr. G. Martinez, and this is your 8th grade science channel. Today we're going to be talking about energy transformations, your TEKS 6.9 letter C. And I hope you guys saw the little intro video and I hope you like it. What you saw there is when nuclear reactions. This is what happens when we split the nucleus of the atoms of certain elements that are radioactive in nature. So today we're talking about energy transformation. So let's get started right away. Now on Friday you were given this. You were supposed to just do something very simple stuff, right? Like for example, you were supposed to write down what the type of energy was underneath this flip, and to write down the law of conservation of energy. Energy cannot be created nor destroyed. It can only change from one form to another. And then you had all the different types of energies, starting from sound, right? Then radiant energy, thermal energy, electrical, mechanical, gravitational, elastic, nuclear, and chemical. And if you notice, all these ones over here have kinetic energy because they requires some type of movement. And these ones were all type of potential energies, right? Neither of these last four for potential energy have movement. So this one was supposed to go on page number 20 of your composition book, okay? Working on today. Today we were looking at this in the classroom. And this was the type of energy transformations they happen. The other example was the flashlight. And as you can see, the flashlight started first with chemical energy because the batteries must preserve some kind of energy inside in order to convert it to electrical. So the type of energy that it has first is chemical. Chemical energy is able to save the energy and then convert it into electrical. Right? After electrical energy, once you turn this switch on, it can also, or it's going to turn into radiant energy. Radiant energy, remember, is light. And sometimes you can even go further than that. Like, for example, after a while having this thing on, it's going to produce heat, right? It's going to get a little hot, so therefore it can be thermal energy. All right, so those are some of the examples that you were supposed to work, and I encourage you to do the rest on your own. By the way, this one is page 22, so keep that in mind. All right, so just remember that you're going to be having a test on Wednesday, 2 days from now. And you're going to be, well, actually, there's two questions that are going to come out from this diagram. So I want you to be able to copy the little notes that we have, okay? For example, over here in this section, this is the big towers that you guys see on the nuclear reactors. And those big towers, you can see some smoke coming in, but the smoke is not bad. All it is water vapor, okay? That water vapor is because the hot water that comes from the reactor is cooling down. So it produces a lot of vapor and then it's released on the air. So let's just start over here. This is the boiler, what we call the boiler, or also where all the radioactive material is what we call the core area, right? So on your composition books, you're going to be adding here that this is your nuclear reactor. All right. And on the nuclear reactor, you have one thing going on, all right? First, the atoms, or better known, the nucleus of the atoms are split. And obviously, when the splitting of the atom occurs through fission, is what we call nuclear fission. Don't worry too much about this name, right? Through fission, then heat is produced, writing these little notes, right? So what happens during this time? What happens here is the nuclear reactor, as this thing is reacting, right? Is the nucleus are being split, it produces a lot of heat. The cold water here that is being pumped into this boiler, well, is actually like cooling down the reactor. And as that happens, the water gets very hot. And the hot water is going to be obviously become lighter and becomes steam. The steam is going to be traveling through this pipe into the turbine, all right? So we're going to be adding a little note over here. We're going to put that water gets hot, right? And turns into steam. There you go. This is the area where this is happening. So this area right here and this area right here. So the water getting very hot. It's going to turning into steam and then it's going to travel this way. All right. So this is the area where pressurized steam keeps moving down on this direction. As you can see, this is a closed system. So as it moves through this area where the turbine is, moves the magnets or the turbine. This turbine has some huge magnets creating a magnetic field, right? This is where the electrical generator happens. So moves the turbine, producing electricity. All right, so as the steam moves down, and eventually in this area it's going to be cooling down. As it moves down, it's going to be turning that turbine, right? So that's the whole purpose of having this type of reactor. And over here, as you can see, this is the area where the electrical poles have those wires, and they're going to be transmitting those wires home to the city or to the grid, right? So here electricity is ready for consumption. Okay. Now let's take a look at this is the area where what we call the cooling towers, all right? And on the cooling towers, hot water, as you can see over here, this area, the hot water is coming in and then it's sprayed into this area where you have the cold water coming from the lake or a river, and just by contact that water is going to be cooling down, and then once it's cool enough or it's cold enough, it's going to be returned back into the cycle so it can be later pumped back into the boiler area. Right, so there you go. It's kind of like a rotating thing, a closed cycle. Over here, the cold water is pumped again towards the boiler. All right, and this is the area. Oh, this is the area where everything is cooling down, and this is the pump that's gonna push it back in there. All right, it's the water pump. As you can see, the water goes into this area and then goes in here. Over here is just gonna get hot, and the whole thing is gonna cycle again. All right, so that's all I have. I hope you guys put the notes together in your composition books on page 22. Here it is, page 22. All right, we'll see you guys later. Bye bye.